Assalamualaikum and a very good day. My name is Ika Elena binti Abdul Rahim and my team members are Elsie Layu, Abdul Muiz bin Muhammad Shukri, Nurul Afikah binti Zulkifli, and we are from 4 BMMP 1/2. Today we will present our project automotive design. As we all know, automotive manufacturing industry is one of the world's most important economic sector. Some of the processes used in the automotive manufacturing industry are stamping, casting, molding, forging, heat treatment, press, welding, and painting. Car production entails the fabrication and assembly of approximately 30,000 individual parts, and it necessitates extreme precision and cutting-edge technologies. Component that our team have chosen is steering knuckle front C. The steering knuckle is an important automotive component that is linked to the suspension system. It helps the steering arm to turn the front wheel while also supporting the vehicle's vertical weight. With the use of a kingpin, the steering knuckle connects the stop axle, tie rod, and axle housing, which are all connected to the suspension system. With the help of a bearing, the wheel hub is attached to the steering knuckle. The primary role of steering knuckle front C is to transform the linear motion of the tie rod into angular motion of the stop axle. The qualities of a steering knuckles are required in the automobile industry to be as strong, rigid, and light as possible.
Hi, my name is Abdul bin Muhammad Shukri. So I will explain more detail in the manufacturing process of the steering knuckle front C. The manufacturing process are divided into the 4 part, which is the CNC rotor machining. I will explain the more detail, and then the sand casting. Sila you will explain about that, and then the CNC machining 5 axis I will explain, and then the drilling Ikayana will explain for the drilling process. So the CNC rotor machine, for the first one, we have been done to design the pattern making, and then to the next process we cutting the pattern machining process, and then we cut the pencil cutting the wooden block, and then we proceed to the milling process for the pattern making. In the CNC rotor machining, there are 6 steps, 6 process have been done. So for the first one, we have been done to design the pattern making, and then for the second one, we programming by using the CATIA V5 software, and then for the third step, we generate the NC code for the CATIA, and then for the fourth step, we cutting the pattern process on the CNC rotor machine. 5th step is the bandsaw cutting, which is we cut the wooden block, and then for the last one, milling process. Okay, for the design pattern of the casting, the pattern is not as straightforward as the definition implies. And then before the starting the product design, we measure the size of the wooden block first before making the design. The size of the wooden block is 105 mm high, 201 mm for the length, and then 157 for the width. So next, we making the design pattern while using in SolidWorks, and then transfer to the CATIA V5 for the pattern making. So by the following the creation of the product design in the SolidWorks software, and then we move to the CATIA V5 version software for the CNC rotor machining program. So all the part operation process have been set up while using the tool of end mill diameter 6 and the ball mill diameter 4. So the type of the cutting process have been selected. So we use the roughing process, facing process, profile contouring process, and then the isoparametric machining for the cutting process in the CATIA V5 software. So after the complete the machining process, we generate the NC code, and then the pattern was fabricated by using the wooden block. Okay, next, we have been done the programming CATIA V5 cutting process. We achieve the roughing, facing, profile contouring, and then the isoparametric machining. So, the CNC rotor machine used to cut the wide variety of the material, which is the wooden block. So the size is I mentioned for the last slide, which is all the part operation process have been set up with the tool and mill D6 and ball mill D4. So the type of the cutting machining process have been selected. We use the roughing, facing, profile contouring, and isoparametric machining for the cutting process. So for the firstly, the advanced machining programming, which is we use the CATIA V5 version, have been created. The process is we use the two tools used, which is the end mill diameter 6 and then the ball mill diameter 4. So in the end mill diameter 6, we use roughing, facing, and profile contouring process. For the ball mill diameter 4, we use the isoparametric machining process for the radius. After that, we running the machining animation to review the shape that we need for the mold pattern. So as we can see, the figure at the bottom shows the animation of the advanced machining process Streering Knuckle from C. The left side has been done running. So they can indicated that the process is carried out according to the desired form. So the blocks used to form the pattern making in the wooden blocks. Okay, after we created the programming machining the both side of the Streering Knuckle from C, the NC code are generated. So the figure shows the part of the NC code for the machining process pattern making. Then the NC code was installed to the PC for the CNC rotor machining to make the pattern mold. So the selector of the block of wood drilled first to the left and right, both sides, in order to be set up in the CNC rotor machine tables. So a hole is drilled to hold the block of wood on the pin table, and then allowing the block of wood to be carried out in a fixed state during the machining process. So the pattern is fabricated by using the wooden block or using two tools of the end mill D6 and then ball mill D4 selected for the cutting machining process. So by the following that, once everything is in the place, CNC machining programming is carried out. So as we can see, the figure of the cutting pattern process shows the process shape of the pattern that is cut the both side while using the CNC rotor machine. So next, the block is chamfer by using the Makita LB 1200F for the bandsaw machine. So the purpose of the chamfering the pattern is to make it easier to remove from the compacted sand. So it carefully to cut to get even a surface of the pattern. So then the surface was removed is smoothened by using milling machine to get the flat surface of the pattern mold. So as we can see, the figure at the top show the pattern mold after it has been complete through the machining process. So the two pieces will be pinned together so that they can join together. The process drill is employed in the pinhole process. The hole is created using a drill bit with an 8mm diameter. So as we can see the picture, the left and right side of the pattern making mold we combine and then proceed to the casting process.
Hello everyone, my name is Elsie and today I will be presenting about one of the manufacturing processes that we have done for our project. Basically there are 4, so my part will be presenting about the sand casting. So basically, sand casting is typically 90% made of silica and plus with binders such as clay to hold them together. So as for our project, generally there are 6 important steps that have to be done to complete the process of sand casting. Alright, so the first step of casting process is of course to have a mold pattern, and the mold pattern will be placed in the casting that will be filled with sand later. So the mold will directly influence the size and the shape of the casting afterwards. Also, when the cast is filled with sand, it will become carefully compact to remove the air trap in the sand. The second step of casting process is by stepping up the getting system for the mold cavity. So getting system is actually used to funnel the molten mold into the mold cavity during pouring the molten into the cavity. After the getting system is already set up, the mold pattern can be removed from the sand. So the mold pattern is no longer relevant at this point. When the mold pattern is placed in the sand, it takes the shape, the sand takes the shape of the pattern. So as a result, the mold can be removed right after the getting system. So the next process will be pouring the molten metal into the mold cavity. So at this process, it will be a little bit critical because you have to be very careful to not over pour it or too fast pouring into the getting system, and avoid to over pouring the getting system, because by over pouring it will affect the look of the finishing product. So the sand casting actually support various type of metal and alloy that will be include iron, steel, aluminum, magnesium, and a lot more. So by depending on the specific metal or alloy that is being used, you might need to melt the metal up to 1684 degrees Celsius. So once the metal or alloy has turned from solid state to liquid state, it is time to pour the molten metal into the mold cavity very carefully. So after the critical stage, we move to the easy stage, which is by waiting for the metal to cool down. After the molten metal has been poured into the mold cavity, it is time to wait it to cool down, and again by using different type of mold, by using different type of alloy or metal, it takes different length of time to cool down. As the molten metal is cool, it will revert back the state of the metal from liquid back to a solid state. Finally, the last stage of sand casting process is by breaking open the mold to remove the metal casting. Basically, the mold pattern are typically reusable, however, the actual mold are not. So therefore, we are ready to move to the next process that will be presenting by my friends. And I think that is all from me about explaining the process of sand casting. So, thank you.
Okay, next, the CNC machining 5 axis. So the next process is to make the hole in the center of the desired product. So while using the CATIA V5 was used to program the CNC machining. So we use the end mill diameter 8 and then the drilling diameter 8 and drilling the diameter 6 process are the tool points that have been employed. So the profile contouring and the pocketing are two process that are used. So after that, the drill for the remaining 3 holes. So NC code was generated for the object. By following that, the NC programming code is loaded into the CNC machine, which is we use the GMU60 Evo model are used to carry out the hole making procedure. So the next step is we place the product on the machine table and align it with the machine. Beside that, we making a hole at the product because the machine we set manual for the center point. So the next step is we place the product on the machine and then the line. So in order to accommodate the product shape, just the top hole has been drilled. So this is due to the fact that the table factor cannot be rotated vertically for the more than 90 degrees. So the edge of hole are consequently created by manually drilling, then by using the drilling machine. So Ikayana will explain more detail in the drilling machine. Thank you from me.
Last process is drilling process. Drillers are tools used to cut away fine shaving of part as the drill advances in rotational motion through the material. To produce hole in the product, 2 tool points were employed. The first hole measured 8 mm in diameter, while the second measured 6 mm in diameter, referred to the figure below. To begin, we use a vernier caliper and chalk marker to measure and mark the product to make holes. Next, the tools were then set up on the drilling machine for the drilling procedure.
Hi, I am Nurul Afika binti Zulkifli and I am going to present our discussion. Our part, which is steering knuckle, have a defect at the side of the part, which is called a misrun. Misrun is an unfilled portion or empty space in the mold. So how this happen? It is believed that the molten metal solidifies early as it is poured into the mold cavity. It is also occurs because of the mishandling during the sandcasting process. So the countermeasure for this defect is we must check the mold design, the gating system, and the molten metal fluidity. We must ensure that the molten metal fluidity is at its optimum rates so that the molten metal can fill up all the cavity inside the mold. In conclusion, this project has impressively improved the skills on product selection that require the suitable process to be developed. Hence, it allows us to be particular on designing the product and the mold pattern by using CATIA software and the CNC router machine. Even though the designing process and machining were done by using modern software, the finishing process of every stages need to be done manually by using a conventional equipment. For example, the mold pattern need to be milled by using a milling machine. Also, the mold making and sand casting process were done manually, where it requires on our energy and skills. So as the product finish, the defect causes and the countermeasure were discussed. Overall, this project has given us the opportunity to understand and have a real life experience to develop automotive part that we have selected, which is a steering knuckle. So that is all from us. Thank you very much.